All right, so let's move on to C part 2. So here I have x over 4 minus 2 equals 3. And so the first thing I need to do is get the x tiles by themselves. To cancel out two negatives, I can add in two positives. Notice that when I plus 2, these cancel out. Plus 2. But whatever I do to one side, I need to do to the other side of my scale. So let's add 2 to this side. So 3 negatives plus 2 positive. Those cancel out, leaving me with 1 negative. Right, and I still have x over 4 on this side. All right, that fourth of an x. So now when I have a fraction, right, I don't have a complete x yet. So I want to keep adding parts until I make up my full x. So if I add another part, to balance it out, I need another negative here. I'm going to click on the empty space to flip it over. Okay, so now it's balanced. Here I have 3/4 of an x, 3 parts. Right, need another negative 1. Right, and let's add our last fourth of an x. And we need another negative 1. So notice that I'm taking my original x and I'm multiplying it by 4. I have 4 of these parts. I'm timesing by 4. And this negative 1, notice that I quadrupled it. I have 4 of these tiles now. I times that by 4. So to make one full x, notice that these 4 parts make a complete x. I need 4 of these negatives. X equals negative 4. Okay, let's go over to C part 3. So here I have 5x over 2. Again, what this means is that I have 5 parts. Each of these are half an x. Again, notice that 2 of these parts make a full x. So I have 5x over 2. I have 5 parts where half an x equals 2. And over here I have 15. So the first thing I can do is, since I have multiple x's, I can divide both sides into 5 groups. So let's divide this into 5 sections. Okay, so let's sort these into 5 groups. So after dividing it by 5, I can divide this other side by 5. Let's divide these into 5 groups. And notice that half an x weighs the same as 3. So know that half an x, x over 2, weighs the same as 15 divided by 5 is 3. Okay? But I don't want to figure out what half an x is. Again, I want to figure out what one full x is. So I know that I need 2 parts, 2 halves to make one whole x. I need to multiply it by 2. So I need times 2 to get one full x. But if I double these sides, I need to double this side. Notice that I need 2 of these 3's in order to get one full size x. So I still need to double this side here. So I see that one full tile, one full x, weighs the same as 6 of these squares. Okay, and C4 is going to be similar to the last problem. Here it has 3x over 4. So notice that I have 3 tiles, and each tile, or it takes 4 tiles to make one full rectangle. So I can start things off by dividing it into 3 sections, divided by 3, divided by 3. So let's divide these into 3 sections. All right, if I divide these into 3, I can divide 6 into 3 sections. So let's divide this into 3 sections. So I notice that I have x over 4 now. I have 1/4 of an x. And 6 divided by 3 is 2. Okay. Now, if I want to figure out one full x, I know that when I add another 1/4 of an x, right, since each of these pieces weighs 2, if I add this extra tile here, I need to add in 2 more tiles over here to keep it balanced. So, combine everything together. If I want one full x now, notice that one full rectangle, I need 8 of these tiles. So, if I quadruple everything I have, times 4, times 4, right, one complete x, one complete rectangle, 2 times 4, this should be the same as 8. Okay. So now moving away from the visual, section D is just using the numbers to solve. So here, I have x over 4 plus 2 equals 6. So to get x by itself, I need to, sorry about that, I need to subtract 2 on both sides. Okay, so minus 2, minus 2. That leaves me with, I still have x over 4 on the left because these cancel out. These are going to cancel out. And 6 minus 2 equals 4. Okay. So now that I have a fraction of x, remember that I need to multiply by 4 in order to get 1 full x. And if I multiply this side into 4 parts, I then multiply this by 4. So if I times it by 4, I get 1 full x now. And 4 times 4 is 16. Okay. Moving on to D part 2. Here, if I want to get rid of minus 7, I need to add 7. And whatever I do to one side, I need to do to the other side to keep it balanced. So notice that negative 7 plus 7 are going to cancel out, leaving me with just 9x. And 11 plus 7, that's going to be 18. From there, since I have 9 of these x's, I can sort them, I can divide them into 9 groups. So I can divide these into 9 sections. But if I divide these into 9, I just need to divide this side by 9 groups. So, divided into 9 parts, I have x by itself now. And 18 sorted into 9 groups equals 2. Okay, and then finally, we have 2 more, D3. It doesn't always have to be x. We can use any letter we want. So, first to get rid of these negative 5s, the opposite of negative 5 is by adding 5 plus 5. And whatever we do to one side, we need to do to the other, plus 5. Notice that these negative and positives are going to cancel out, leaving me with n over 20. And that's going to be the same as, let's see, 4 negatives, 5 positive. These are going to cancel out. It's going to equal positive 1. And again, since n over 20 is divided into parts, to get 1 full x, I need to times it by 20. Okay. But whatever I do to one side, I need to do to the other. Multiply this side by 20. So now that I multiply it by 20 parts, it becomes 1 full rectangle. And 1 times 20 is 20. Okay. And finally, for the last problem, okay. So I want to get a by itself. So I need to start off by getting rid of these 6. Okay. But if I subtract 6 on one side, I need to subtract 6 on the other. So I'm left with negative 4a. Whoops, because these are going to cancel out. So I'm left with just this negative 4a. Equals 18 minus 6, that's going to be 12. Okay. Now that I have 4 of these, I can now divide these into 4 groups. So I can now divide it by 4. So now I have a negative a equals 12 divided by 4 groups. I get 3 each. Okay. And the last thing we talked about was flipping the sign. I can multiply this by negative 1. Multiply this by negative 1. So if I multiply both sides by negative 1, a flips over to being positive, and 3 flips over to being negative 3. So that's how we solve this problem. So our focus question, how do we solve for equation? What's our goal? Our goal is to get x by itself. And what steps can we take to solve for x? We can add or subtract tiles to both sides in order to cancel out. If we have a fraction of an x, we can multiply both sides to get 1 full x. And if we have multiple x's, we can divide both sides into groups. So those are just some of the reasons why we do certain math operations. Why when we divide, we have to multiply to cancel out. When we have multiplication, where we have to divide to cancel out. So I just wanted to show you guys a visual way of why we do certain things when we solve equations. Okay. If you still have questions, feel free to email me back and I can update this video. Okay. All right. Thank you.